Evening, everybody. Tonight we're going to be looking at solving equations. I want to start off with a really big picture. I wanted to show you one of the most complicated problems that you might run across. Obviously there's more complicated than this, but that way we can look at all the features and all the steps. And then tomorrow we'll consolidate down to some easier problems. But for tonight I want you to focus on the system of how we work through a problem every single time. And then sometimes you'll see those issues and sometimes you won't. But for this particular problem we'll solve tonight, it will involve all the issues most likely that you'll see. So with that said, I'm going to put a problem up on the board and we'll get started. So as you can see, we have a pretty nasty problem up on the board here with all kinds of things going on. And so where do we start? So I want you to follow this acronym, S, I, D. And the first thing you're always going to do is you're going to simplify. Okay? And so when we talked about practicing simplifying and combining like terms, well, simplify meant that we were going to deal with the distributive property and we were going to deal with combining like terms. So in this particular problem, do we have parentheses? Yes. So whenever we see parentheses, we're going to deal with the distributive property. So I'm going to use the distributive property, 3 times x, 3 times 2, and I'm going to get 3x plus 6 plus 2x plus 6 equals 3x plus 8 minus x plus 10. And you can see I write the whole problem back over again. Simplify, I'm telling you that we need to do 2 steps. We need to check that we've done the distributive property. Have we gotten rid of all the parentheses? Well, the answer is yes. The next step with simplifying is we combine like terms. So I'm underlining my 3x, I'm looking, I find another x. So I have 5x. I'm looking, I've got 6 plus 6, so that's plus 12. And now I'm looking over here, I've got 3x minus x, which gives me 2x, and I have 8 plus 10, which gives me 18. So, simplify, combining like distributive property and combining like terms. I'm going to erase that so I can have a little room here. Okay, so we've got my simplify. Check. Isolate. Well, what does it mean to be isolated? It means that I, as a person, I'm on my own. Well, in this particular case, isolate means that I want my x, or my variable in general, on its own. Now we can have more than one. We can have 6 x's, we can have 7 x's, but I just want the variables on their own. Well, let's take a look at this. We're talking about something in class yesterday about balance and how I was allowed to subtract from one side if I do it to the other side. Here I have 5 x's hanging out on one side of my line, my equation, and on the other side I have 2 x's. So if I want to get rid of x's on one side, I have more on this, less on this, so I'm going to subtract 2x. Well, as we talked about in class, if I subtract one thing from one side, I have to subtract it from the other side. So in this case, I have 5x minus 2x, and I'm going to move this problem down here now to give myself a little room. I have 3x. I still have my plus 12. 2x minus 2x is gone, and I'm left with 18. So we are trying to isolate the variables. Is my variable on its own? Well, no, it still has a plus 12 attached to it. Okay, so again, we said if we want to get rid of something, we can do the opposite. 12 minus 12 gives me 0. 3x equals 6. Now this property right here, where we add the opposite, is called the additive inverse. So if I have a negative 12, I'm going to add its opposite. If I have a positive 6, I'm going to add its opposite. So whatever value I have, I'm going to add its opposite. Whenever you add the opposite of a number, you will always end up with 0, and that is the definition of the additive inverse. What number can I add to this number so that the sum is equal to 0? And so basically we're just switching the signs. And as we talked about in class, as long as I do the same thing on both sides, then it's okay. So on this particular situation, I didn't like having a positive 12, so I add its opposite, negative 12. As long as I come over here and add a negative 12, then I've kept everything in balance. So now I have 3x equals 6. Is my variable on its own? Well, yes. I have 3 of them. I have 3 x's, but my variables, or my variable, is on its own. There are no numbers attached to it. Okay, so we can check that block off. And the last one is divide. And we'll talk a little more about this and how it's not really dividing but multiplying, but I think for most of you, and when you initially get started, you can see the division. So, divide. Well, what am I talking about here? Well, I have 3x equals 6. My goal is always to get x, goal is always to get x equals something. Well, right now I have 3x equals something. How do I turn a 3 into a 1? I divide it by itself. How do I turn a 5 into a 1? I divide it by itself. Okay? This is called the multiplicative inverse, because really what you're doing is you're taking 3 and multiplying it by its inverse. 3 times 1 is 3. 1 times 3 is 3, and that equals 1. How do I turn 5 into 1? The multiplicative inverse says I just flip it. And so in fact we could do something even more complicated. Okay, if I want to change this into a 1, how would I change 2/3 into a 1? Well, the multiplicative inverse would say multiply it by its inverse. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 equals 1. And you can use this for anything. So how do I turn this 3 into a 1? Well, you could think of it as dividing by 3 or multiplying by its multiplicative inverse. So 2 big words tonight. Additive inverse, add 2 numbers together till we end up with 0. Multiplicative inverse, multiply 2 numbers together so we end up with 1. So using this piece of information, what do I multiply or divide by in order to get my 3x to a 1x? Well, I can go and divide both sides by 3. 3 divided by 3 gives me just x. 6 divided by 3 gives me 2. Or, if you wanted to, 3x equals 6. Multiply this side by 1/3. What I do on one side, I do on the other. And I think for a lot of you, you'd prefer to divide by a whole number than multiply by a fraction. Obviously, when the coefficient, remember this is called a coefficient, is a fraction, then you're going to have to reach out and learn that. Although if you have half an x, we say divide. How do you divide by a half? Well, divide by a half is the same as multiplying by its inverse, correct? So how do you get rid of a half x? Multiply by 2. All right, so that's a very, very large overview of what we're going to be doing for the next 2 weeks. I don't want you to panic if you don't get all the details. What I do want you to understand is that no matter what we do, we are going to simplify by using the distributive property and combining like terms. Once we've done that, and only when we've done that, will we isolate the variable. We will make sure that we just have a number of x's on their own and the value that it's equal to on the other side. And then finally, to finish off the problem, we're going to divide out the coefficient. If this is 3, we divide by 3. If this is 5, we divide by 5. And as I talked briefly, if it's a fraction, we divide by the fraction, which is the same as multiplying by its inverse. I will get into talking about a check step, and you can ask me about that tomorrow. But for now, I want you to go to the practice quiz. The practice quiz, we will say, is number 16. Okay? Remember, big things from the lesson tonight. Simplify, isolate, divide. Go through this a few times. Make sure you track along what I have. And if you have any questions, I want you to input those into the post-quiz so that we can discuss them in class. We will have lots of time tomorrow to discuss this, so don't panic. I'll talk to you soon. Bye-bye.